Hi. I am firing up the stream right now. And I need this over. Nope, I want you down. Alright, so welcome to the first AP Bio stream. We're going to be talking about the nervous system. And I just want to start off with I miss you all very, very much. I call this the Corona Chronicles, and we're actually on Corona Chronicles 4.0 today. My chemistry kids have heard the Corona Chronicles 1.0, 2.0, and 3.0. You are getting Corona Chronicle 4.0 in the nervous system, and I just want to share with you all the wild and crazy things that have been going on at Chateau Vandergoot these days, because life is just not the same. You know, we spent the first day making a leprechaun trap for St. Patrick's Day, because apparently leprechauns invade your home and they need to be trapped, and you know, he escaped. He did not get trapped, so then it led to leprechaun trapping 2.0, where we had to change the design and make a completely different leprechaun trap. We painted, we cooked, we baked. My kids are driving me absolutely insane. I miss you all very, very much. So, I just want to take a minute. There is a live chat bar. I'm just going to pull up what you're seeing right now. There is a live chat bar over here. So just take a minute right now and just give me the thumbs up that you're with me. Just, you know, say hi. Let me know that you're alive and well. And I'm going to get into the nervous system. So take a minute. Give me the thumbs up. Let me know that you are with me. And you can hear me. You can see me. And everything is good. The volume is really low. Okay. So take a minute. Give me the thumbs up. Can you turn the volume up on your computer? And you can hear me. You can see. Let me just see if I can change one thing over here. The volume is really low. Okay. So take a minute. Give me the thumbs up. Can you turn the volume up on your computer? And you can hear me. You can see. Let me just see if I can change one thing over here. The volume is really low. Okay. Let me check one thing. Can you turn the volume up on your computer? Not what I meant to do. Hold on. Let me check one thing over here. Hello? Yep, no, it says that my audio is good. So just check you, make sure that your volume is all the way up. It's on all the way, but it's really hard to hear. Michelle, can you hear me? Is it a matter of Sophia's computer, or is it me? Audio is good. So just check you, make sure that your volume is all the way up. It's on all the way, but it's really hard to hear. Michelle, can you hear me? Is it a matter of Sophia's computer, or is it me? So just check you, make sure that your volume is all the way up. Lillian Mystery, are you Lily Gotch? Michelle, can you hear me? I would assume you're Lily Gotch. Lillian Mystery, are you Lily Gotch? Okay, Sophia, did that get any better? Because I played with the input where my microphone is. Okay. Okay, Sophia, did that get any better? Because I played with the input where my microphone is. Alright, Sophia, my suggestion would be maybe try headphones. Like, plug headphones into whatever device it is. Okay. Okay. Alright, I'm going to wait for you to switch to your phone. Just give me the thumbs up that we're ready to go. I see Sophia, I see Michelle, I see Lily. And it says right now that we have 5 of you watching. That makes about sense. 1, 2, 3. That sounds about right. So 6 of you watching. So just take a minute really quick and say hi. Just let me know that you're here. Michelle, I see Lily. And then we're going to dive into the nervous system. 5 of you watching. That makes about sense. 1, 2, 3. That sounds about right. So 6 of you watching. So just take a minute really quick and say hi. Just let me know. You're very mysterious. I understand, Lily. It makes sense. Okay. Alright, Sophia, give me the thumbs up when you're ready to roll. And just keep in mind that there's a 30-second delay between when I'm speaking versus what's showing up on YouTube. So I might pause and you might be like, this is taking forever. But it's sometimes a matter of I'm just waiting for the delay to catch up. There's about a 30-second delay. Good. Good on your phone. Awesome. Alright, so here's what we're going to do. Hopefully you took the time to print the diagrams that were on the website. Give me the thumbs up really quick. Make sure you got diagrams. Otherwise, I'll show you where you need to find them, because we're going to be taking notes on the diagrams. The last page of the diagram should be blank, and I want to take a minute, and on that diagram, the back page where it's blank, I want to talk to you really quick just overall about the nervous system. There are two different segments of the nervous system. There is something that we call the central nervous system, and I want to take a minute, and on that diagram, the back page, and there is something that we call the peripheral nervous system. So there are two different segments: central versus peripheral nervous system. It's definitely not how you spell peripheral. Okay, so central versus peripheral. And when I think of the central nervous system, I think the central nervous system, I'm thinking about processing. I'm thinking about the interpretation of information and decision making in order for you to turn around and have some sort of response that can be executed. So underneath here, I'm going to just make a little bulleted list. When I think of the central nervous system, I'm going with processing. That's the number one stunner in my mind as to what the central nervous system is responsible for. The processing of information and then the decision making of how you're going to respond. Okay, the central nervous system is comprised of your brain and your spinal cord. And that's all well and good. I think of it's really important here that you have this processing unit that's able to process information, make a decision, and then have some sort of response that the rest of the body can then turn around and act on. The acting part of the nervous system, the part that's actually responsible for, receiving a message and then actually executing the message, that's a completely different part of the nervous system. So, and I hear my daughter screaming upstairs, so don't be surprised if all of a sudden you hear Amelia come barging in here looking for me. And you're probably going to get to say hi to her, which is really interesting because one of the many things that we've been doing during the Corona Chronicles is we've been watching an absurd amount of YouTube. Like, more than any parent should be proud to admit that their child is watching YouTube. And a long time ago, my daughter asked me if she could possibly, have her own stream on YouTube. Keep in mind, she's 6. She told me probably 6 months ago that I'm not doing my makeup well enough and I need to contour more. She learned it on YouTube. And she wanted to start her own streaming channel. And I told her no, like 6 months ago. Well, one of the things that she did on YouTube this past week is she searched my name and found out that I have a YouTube stream. And she was very, very confused as to why I was allowed to have a YouTube stream. But she's not allowed to. That happened. So, don't be surprised if she comes down here because she's been dying to say hi on YouTube to anybody. Okay. The peripheral nervous system, instead of processing, I think of they're responsible for the receiving of messages and then receiving and execution of said messages that are being returned back. The peripheral nervous system, when I think of periphery, okay, I think of the edge. I think of the outlying regions. I think of, people who are like, oh, we're going to go check the periphery and see what's going on in the perimeter. That's what I think of periphery, that outside environment that is responsible for sensing what is going on in the outside environment. And then, that outside part of the central nervous system, it's outside of that core brain and spinal cord. You're talking about the nerves that are in like your feet and your arms, in your extremities. That would be another really good word, like extremity. Outside the central nervous system, that's going to send a message to the processing center. Processing center will turn around and be like, yep, that's not good. Or they'll be like, that's awesome. And they'll make a decision as to how they're going to react. Okay, the peripheral nervous system is going to pretty much be any sort of system, any sort of structure outside the central nervous system that is capable of receiving stimulus and then also being able to then respond to stimulus outside of the central nervous system. Okay, there is a breakdown in the peripheral nervous system. There's 2 categories. So I'm going to add a little bit of a split in here in this little flow chart of information. And I'm going to continue here. The peripheral nervous system can be split into 2 different categories. There is something called the somatic nervous system. And I'm going to drag this out so I can get a versus in here. Okay, somatic nervous system versus the autonomic, it's not how you spell autonomic, autonomic nervous system. Let me drag this out. Okay, and the big distinction here, somatic versus autonomic, or the way I like to think of it, I think this sounds just like automatic. That is kind of how I'm thinking about it. things that happen like automatically inside of the body. Okay, and so the big distinction here, somatic versus autonomic, because it doesn't want to behave. The way I like to think of it, I think this sounds just like automatic here. That is kind of how and then I'm going to bring things that happen like automatically. Okay, and I'm going to bring this line over here. Beautiful. Somatic versus autonomic. Okay, somatic peripheral, in the peripheral system, when you're talking about something somatic, okay, somatic is going to be any sort of organ or structure that is capable of doing a voluntary response. Like, you want to do something voluntary, like I think like, hey, like I'm going to go for a jog, which I know like nobody really wants to go jogging voluntarily, but let's say you voluntarily want to go for a jog. Like, you are making a voluntary decision to like use the muscles that are inside of your legs. Like, you're making a decision when you like pick up your cup of coffee and like you drink out of it. You're making a decision when you pick up your pen and you start writing. All of those things would be considered a voluntary response, because like you can think about it and then decide, do I really want to go for that jog? Do I really want to drink that cup of coffee? Like, do I really want to go take those notes? All of those things would be something that you are making a conscious decision, and that would be a voluntary response. So, voluntary. And that definitely is not spelled right, and it definitely needs to be shrunk down. So, let's do that. All of those things would be voluntary responses. Okay, as opposed to, when you think about an autonomic peripheral nervous system response, or an or an automatic peripheral nervous system. Okay, I'm thinking about things that automatically happen that like you don't think about, but require some sort of nervous system regulation. And I'm thinking about, well, the muscles like in your heart. Like the muscles in your heart, they're beating. They're beating because they are getting a electrical stimulus from the brain that's telling you to like, keep the rhythm of the heart consistent. I want to copy and paste this. So anything that is autonomic is going to be what I refer to as automatic, things that you are not thinking about doing. Keep the rhythm of the heart consistent. And I'm thinking about, in that case, things like your heartbeat. Okay, do you have to like ask your heart to beat, or like does your heart beat like kind of like automatically on its own? Okay, or I'm thinking about like your diaphragm. Like, do you have to think about breathing? Like, or does your diaphragm like naturally get the message, and your those muscles are doing what they need to do? Think of your heartbeat. I think of your diaphragm. I think about your digestive system. Like that entire process of like digesting your food. There are muscular contractions that happen like in your esophagus as you're swallowing. Like there are things that are happening like in your small intestine. Like, when was the last time you were like, hey, small intestine, like, do you think you could do some peristalsis for me? Or even like when you get sick and like you throw up, like did you ask your stomach like, hey, like now would be a really good time to do some reverse peristalsis so I can get this out of my body? No, those are all things that happen automatically. I need 2 minutes, just because again I hear my daughter screaming upstairs, and I just want to check on her to make sure she's okay. I want you to give me the thumbs up to make sure we're in a good place, because the next thing I need to do is I need to take you through the parts of the brain. Okay, give me thumbs up. I'll be back in 2 seconds. And I just want to check on her to make sure she's okay. I want you to give me the thumbs up to make sure we're in a good place, because the next thing I need to do is I need to take you through the parts of the brain. Okay, give me thumbs up. I'll be back in 2 seconds. And I just want to check on her to make sure she's okay. I want you to give me the thumbs up to make sure we're in a good place, because the next thing I need to do is I need to take you through the parts of the brain. Okay, give me thumbs up. I'll be back in 2 seconds. And I'm going to apologize right now in advance because I'm out of breath. I just ran up 3 flights of stairs and then down 3 flights of stairs to come back. The craziest was her comforter fell off of her bed. She needed me to tuck her back in. So I'm going to check the sidebar really quick. Right now catch my breath. I'm out of breath. I just ran up 3 flights of stairs and then down 3 flights of stairs to come back. The craziest was her comforter fell off of her bed. She needed me to okay, so really quick, I'm looking at the sidebar. You said there's an echo. Do you hear my voice delayed by like 30 seconds? Twice, because that happened because my speaker was on. I don't think that's what happened. You're just hearing like a normal echo. So really quick, I'm looking at the sidebar. You said there's an echo. Do you hear my voice delayed by like 30 seconds? Twice, because that happened because my speaker was on. I don't think that's what happened. You're just hearing like a normal echo. So really quick, I'm looking at the sidebar. You said there's an echo. I'm checking the bar. I'm waiting for you guys to say something. Delayed by like 30 seconds. And hi, Brandon. I am not Lillian Mystery. I'll give you another guess as to who the Lily mysterious person could be. I'm checking the bar. I'm waiting for you guys to say something. And hi, Brandon. I am not Lillian Mystery. I'll give you another guess as to who the Lily mysterious person could be. We hear you twice. Like 30 seconds apart. Hi, Brandon. Hold on. I am not Lillian Mystery. I know why. I'll give you another guess. I forgot to mute this. Hold on. I have you guys running. And I did not mute this. I just muted it. Tell me if that's better. This is like the 4th time I've streamed, and every time I've done that, I've forgotten to do it. Don't be sorry, Brandon. It's all good. Okay. Is that better? Because I just muted it. Okay, awesome. Hey, Dylan. Okay, great. All right, so summary of the nervous system. I finally caught my breath running up and down the steps. Let's talk the brain. Okay, let's digest this picture. Okay, my goal today is I want to hit the brain with you. I want to talk to you about a neuron. That's this guy. I want to talk to you about the reflex arc, which is more like this guy. And then I think we pause and we stop. And then I think what we'll end up doing is I will stream one more time for you on the nervous system. And I will take you through action potential, which is going to be the last 3 here. And before we go through action potential, what I'm going to have you do tonight after this is all over, you know, you're going to watch me, you're going to watch a stream. Tomorrow over the course of your day, I'm going to ask you to watch a couple videos for me that are going to talk about action potential, and then I will give you notes on action potential. I really could jam this into one larger stream, but I think for the sake of not overwhelming you, I'm going to split this into 2 different streams for you. You know, do it, just make life a lot easier. Okay. Okay, so here we go. If you have colored pens, colored pencils, markers, crayons, whatever you got lying around your house, you might want to color code with me because I'm going to do a little bit of color coding. I'm going to start off with number 1. So I'm going to label as I go. And let's go purple. Number 1 is the thalamus. I'm going to need to shrink that down. Okay, number 1 is the thalamus. So let's shrink this down to like 18-ish, and let's color the thalamus. The thalamus is this little circular area over here. This is going to be the same purple color. Is this little circular area over here. Okay, the thalamus is going to be responsible for, and I'm actually going to pull this out to the side, and I'm going to do a bulleted list with this. So the thalamus is what I refer to as the operator of the brain. Okay, and I think of like somebody who's responsible for answering the phones at a company. Okay, another way that people remember this is they think of this like the relay center, and I think of like a relay race. I think of relaying a message, And basically the moral of the story with the thalamus, and this definitely needs to be shrunk down a whole lot smaller, the moral of the story with the thalamus is that the thalamus is going to be responsible for receiving some sort of electrical message that is coming in from the periphery. So like message comes up, this is the brainstem, message comes up and it's like, hey, like I'm about to touch a hot stove. And the thalamus gets that message like, oh, someone's going to touch a hot stove. And they're like, pause, hold on, let me transfer your call to the motor area. Or another message comes in like, hey, like you're going to be about to be run down by a truck. Like a truck's coming your way. And the message comes into the brainstem like, hey, like there's a truck coming. What should we do? And the relay center goes, hold on, please hold. Let me transfer your call to the panic center of the brain. Or there might be a time and a place, usually about, 12, 13 years old, where a message comes in from the brainstem that's like, hey guys, it's time to start thinking about puberty. Let's do puberty. And the brain goes, oh no, okay, hold on, please hold. Let me put you in touch with the part of the brain that's responsible for the endocrine system. The thalamus is pretty much the operator. The relay center, any sort of message that comes into the brain is going to be received by that thalamus, and the thalamus is going to be like, hold on, let me redirect your call to the appropriate person who can handle your problem. Okay? So, the next one that I want to talk to you about, should we go in order? Yeah, let's go in order. Okay, the next one we should talk about is the cerebrum, which is number 2. I'm going to get this out of here. You need to leave. And let's copy paste you. That's a lie. You are a lie. Copy paste. Nope, it didn't mean to delete you. Copy paste. Yes. Okay, and let's put this over here. And let's go number 2. Number 2 is the cerebrum. Okay, the cerebrum is responsible for many different voluntary responses, as well as higher level brain activity. Okay, if you were to take a look at the cerebrum of other animals, humans have like a disproportionately large cerebrum compared to other animals. It's not to say that other animals can't have like large cerebrums, like larger cerebrums than ours actually is, but I'm talking about like comparative to like the rest of the structures. The cerebrum is pretty much like the majority of what is happening inside the skull of a human being. And the reason why that's so large is because of all the higher level cognitive thinking that we're responsible for doing. Okay, I want to just take a minute and pause the video and, like wait for your responses. Like, what are some things that are uniquely human? Not to say that other animals can't do them, but we just do it at such a larger scale than any other organism on Earth. I want you to take a minute and I want you to start throwing down with some things that are higher level functions that you would find in a mammal, or not even a mammal, a human being, that would attribute the reason why this cerebrum is so large. Take a minute, start typing stuff in the sidebar. I'm waiting for you. No, you can just start typing. Just start typing in the chat. At some point I had mentioned it to my chem kids. I'm thinking that for fun, I usually do my lessons on YouTube just because, it's easier for me to have it just directly record to my stream. But I'm thinking at some point maybe we can do a Zoom, because I know that Zoom, you can actually see like, video and like faces and stuff. You don't have to show your face, but I'm thinking maybe we could, play a game. Like I'm thinking I could write some words that are EP bio and I could put them on my forehead and we can play heads up, like, like the bootleg version where like you can just start yelling things at me and I can try to figure out what word it is that you're telling me about without you actually telling me. So I'm looking right now. Okay, so Sophia said relationships. I can definitely get behind that. Sophia, I'm going to ask you to expand on that. Like what kind of cognitive processing goes into a relationship? You're right, but I'm looking for something that would be like a brain function. Okay, Michelle's throwing down with complex speech. I completely agree with you. So I'm going to make a bulleted list over here. I think of complex speech, and I'm thinking of communication. Language. That's a big one. And it's not to say that other animals can't communicate, like other animals don't have a language, because like other animals do. We just don't necessarily understand them as well. And do I think that the language that other animals are communicating with is as complex as human language? Like, keep in mind like how many dialects there are of human language that's out there. And somebody once said to me, I think it was last year in AP Bio, like, my dog communicates, like my dog speaks to me, like my dog lets me know like he has to go outside and go to the bathroom. And I'm like, yes, but like, does he necessarily have the same extent of language that you do? Hey, Dylan said constructing large structures. Dylan, I'm gonna go and ask you, what kind of cognitive brain function would you need in order to construct a large structure? Lily says quantum physics. Again, like, what kind of brain functioning do you need? Brandon and Sophia's going reading and writing. Brandon saying being able to ask questions. Navigating your live stream. Okay, looking for favorable characteristics in specific partners. Okay, you're going back to the whole relationship thing. I'm going to come back to relationships in a minute. I'm still on this construction of large structures, and I'm seeing reading. I'm seeing writing. Okay, I think reading and writing would fall under the categories of language as well as reasoning. Like, you need to be able to reason. You need to be able to have logic. You need to be able to process large amounts of information. How about this one? Like, learning. Like, being able to learn a behavior. I mean, I don't think that I know other animals can learn behavior, but like, not necessarily in the same way that human beings are. Lily said special awarenesses. Like, I can definitely get behind that statement. Sophia's going here with oh, special awareness. You said spatial awareness. Yes, definitely. So I think that that's part of the reasoning. Maybe we should actually probably throw in here movement, because movement is a higher level cognitive feature. I'm not saying that other animals can't move, but we definitely have a whole lot of more spatial awareness that goes on. Dylan says planning. Yep, I agree. That would be part of the reasoning and the thinking and the logic component. I want to go back to what Sophia said with relationships. And she's thinking about, like evolutionary style, like, looking for favorable characteristics in different partners. I feel like that's an emotional level. So emotions. And I'm not saying that other animals don't experience emotion. Like, I feel like I walk out of the room and my dogs are like so sad. They're like, oh my God, what are we going to do without you for like literally 30 seconds? Or like, my cat looks at me and he's like, I hate you. Not really. But I do feel like other animals do experience emotions, but do they necessarily experience them in the same depths of ways that we do? And then are they able to express them the same way? That is what I'm getting at here when I think of higher level cognitive functions that the cerebrum is responsible for. So let's move on. Okay, I want to take a look at, I'm going to work my way around this picture. I'm going to take a look at number 7. So we're kind of going out of order. Number 7 is the back of this brain area. So actually, if I wanted to highlight, because I think highlighting is a better choice here for the cerebrum, I just got to wait for this to fire up. Come on, highlighter. 2 seconds. Smart Notebook's having a little bit of a brain fart, no pun intended. Okay, the cerebrum would be this entire foldy part of the brain. And let's talk about number 7. So let's put this guy down here. Okay, number 7 is what we refer to as the cerebellum. Okay, and the cerebellum in my mind, I'm going to get rid of this because this is not the definition. The cerebellum in my mind looks like a clam. It looks like a little bit like a clam. This clammy looking structure in the back, clammy looky thingy, is the cerebellum. And the cerebellum is responsible for the coordination of balance. And yeah, it says coordination and balance in my notes over here. So why won't you cooperate? No? Yes? No? 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 So the cerebellum is responsible for coordination and balance. Coordination and balance. You have to forgive me on my spelling. I know my spelling is normally atrocious on like a good day, but Corona Chronicles has proven to just degrade all sense of humanity that I have. Any sort of spelling and counting, yeah, I've given that up. Okay, so I'm actually gonna work my way back up. I went 7. I think the best way to handle this is to go back up. So number 6 is the brainstem. Number 6, brainstem. And the spinal cord. Actually, it's a lie. This entire thing collectively we refer to as the brainstem. The top of the spinal cord is the brainstem, so I'm gonna actually leave in brainstem, but it's like the top, specifically the top part of your spinal cord. Okay, and the brainstem and spinal cord is going to be responsible for the relay of information from the peripheral nervous system to the central nervous system. So definition time. Okay, this would be responsible for receiving or sending. How about connecting? Connecting, lie. Okay, connecting the peripheral nervous system to the central nervous system. Peripheral. Okay, great. Okay, moving on to number 5. Number 5 is the medulla oblongata. And anybody who's watched The Waterboy has definitely heard of the medulla oblongata before. If you have not watched The Waterboy, we're going to watch that clip really quick. And the medulla oblongata is this little bit fatter area of the top of the brainstem and the spinal cord. Let's open a new tab, a new window. Yeah. And let's hop on YouTube. Like you're watching YouTube, like watching me stream on YouTube, and I'm going to show you like a video on YouTube. It's very, very weird. Okay, let's look up medulla oblongata, The Waterboy. Okay, and hopefully you can hear the audio on this. Let me unmute this.
So, why you pick this class anyway? It's pretty hard.
Oh, what a beautiful view.
All right.
All right. Y'all shut up now. Now, last week, we talked about the physiology of the animal brain as it pertains to aggression. Now, is there anyone here that can tell me why most alligators are abnormally aggressive?
I know the answer to this question. Raise your hand.
Anybody? Anyone? Yes or you, sir?
Mama says that alligators are ornery because they got all them teeth but no toothbrush.
Your mama said alligators are ornery because they got all them teeth and no toothbrush. Wow. Anybody else? Yes or you, sir?
Alligators are aggressive because of an enlarged medulla oblongata. It's the sector of the brain which controls aggressive behavior.
That is correct. The medulla oblongata.
But Mama said...
The medulla oblongata is where anger, jealousy, and aggression come from. Now, is there anybody here can tell me where happiness comes from?
No.
Anyone?
Oh.
All right. Let's hear what Mama has to say on the subject.
Mama say that happiness is from magic rays of sunshine that come down when you're feeling blue.
Well, folks, Mama's wrong again.
No, Colonel Sanders, you're wrong. Mama's right.
All right. Mama's right. Mama's right. There's something wrong with his medulla oblongata.
It's okay to fight back. Coach Klein said I could. Mr. Coach Klein said I could. It's fine.
Okay, so in the movie The Waterboy, they're talking about the medulla oblongata, which clearly Adam Sandler does not know what the medulla oblongata is doing, but at the same time, his medulla oblongata is definitely doing its job. The medulla oblongata is responsible for primitive urges. So I want you to take a minute, and no, it definitely doesn't need to be that large. I want you to come up with some primitive urges, and I'm going to actually give the notes to the medulla oblongata. Let's go over here. Medulla oblongata. Nope. Medulla oblongata. I'm going to put the bulleted list over here so I have enough room to type. What are some primitive urges that you can think of that would be necessary at the primitive level for an organism to survive? So take a minute, throw down with some things that are primitive. And I'm going to actually, while you're coming up with that list, I'm just going to put a few other names in here, because you're probably going to give me things that belong in other places. Okay, start typing out some primitive urges. Okay. Alright, so Lillian says eating food. I would definitely agree with you. That is a primitive urge. And in fact, I feel like all three of these, and I'm going to highlight the three, they're responsible for primitive functions, but they're not necessarily responsible for the primitive urge of the medulla oblongata. I'm going to highlight these in pink. So we're going to go primitive, primitive, primitive. And I'm going to start throwing down and organizing the stuff that you're giving me. I'm going to put the hypothalamus stuff here. I'm going to go Pons bulleted list over here and medulla oblongata's list over here. So I'm going to put this here. I'm going to shrink this down to a size 14. And Lillian said things like eating food. I see Michelle Brown saying drinking water. So I'm going to put that in here. I'm going to go with the urges of hunger. That's a hypothalamus function. Okay, things like thirst. That is a hypothalamus function. Sleep. That's actually a really good... Yep. Okay, so sleep. The need for sleep is a hypothalamus function. Keep going. Actually, wait, hold on. Okay, I'm gonna go with... Dylan says mating. So, that's actually a medulla oblongata function. I'm gonna go over here and put that in. Medulla oblongata function. I'm gonna shrink you down. 14. Medulla oblongata, the whole concept of a sex drive. Okay, and that would be definitely a primitive brain function, and it's primitive in the sense that all organisms need to have some sort of desire or sex drive in order to continue the species. Like, that is a very important evolutionary advantage. And while we're on that whole concept of, you know, like sex drive and competition, that is really the function of the medulla oblongata. I want you to think back to that Waterboy video. What did you see Adam Sandler expressing that would be some sort of primitive urge? He's not finding that professor sexually attractive, but there was another primitive urge that Adam Sandler was throwing down with, showing in that video. Okay, Brandon says respiration. Now, Brandon, I just want you to be a little bit more specific here. When you say respiration, what exactly are you talking about? Are you talking about cellular respiration, or are you talking about the process of, like, respiring, which would be different, and that is a different process? Brandon, I need you to be a little bit more specific here. Okay, so Dylan, you say protection. What exactly do you mean by that? Talk to me. Like protection in what sense? Because I think you're on to something here. Go ahead. Choosing what to eat for lunch. So I'm gonna throw in here hunger as part of the hunger component. Anger, love it. Okay, Sophia, you're 100% right. So part of the sex drive, believe it or not, is a primitive function or a primitive drive would be anger. I feel like anger is an emotion, but it's more of like an evolutionary emotion. Like that anger, or another thing that would definitely relate to sex drive over here would be like jealousy. That is another primitive urge. Those are things that are going to drive you to compete. So anger, jealousy. I would throw in here aggression. That is another primitive urge or another primitive function that would be really important if you're thinking about evolutionary biology for the continuation of the species, you know, fighting for what you want. Okay. Brandon said breathing rate. Yep. Okay, so I'm going to put that in. The pons is actually responsible for the breathing. So bulleted list over here. There's not too many things for the pons. I'm going to go breathing rate. And I just got to make this a little bit larger. Okay, breathing rate. Okay, looking. Dylan says a person feels the need to protect or defend the people they love. So, that's actually a really good question. I'm gonna maybe go with jealousy. Like, maybe not just jealousy for something like personal for you, like you're thinking of something that's more of like a, like, what's the right word, like a mutualistic relationship, like you are trying, not even mutualistic, not commensal, I'm trying to think of the self-sacrificing. That would, I like that one. Let's put that in here. I'm gonna put that under medulla oblongata. Like the desire or the need in order to protect what is yours or someone that you care about. Okay, Brandon said heart rate. Yep, so I'm gonna put heart rate in the hypothalamus. That is another primitive function that the hypothalamus is responsible for. What other things are primitive? I'm looking for a couple more things on the sidebar. That's okay. Yeah, there's about a 30-second delay, Brandon, so it's all good. Anything else you can think of? Yes. Yes, so protection. Yeah, that was that was the word that I was looking for, an altruistic relationship. Altruism. Good. So hunger, thirst, sleep, heart rate. I'm going to throw in here another primitive function would be like waste removal, so excretion. And that can come in a lot of different forms. For human beings, that would be the kidneys. And then another one that I'm thinking of is going to be some sort of transport system, the need to regulate transport. And in this case, for a human being, we're talking about the regulation of blood flow. So I think we hit everything that I needed to say to you on the brain. Let's digest a neuron. Let's move on to this. And then I think my goal today was to get to this, and you know how AP Bio always goes. We never quite finish everything that we want to, but that's totally fine. Let's at least get through this diagram. We'll assess the time and then make the executive decision as to when we will pick up again, if I can get more in and do a reflex arc with you. Otherwise, we might call it a night, call it a day, and then you know, have another stream tomorrow where I can get into more detail with you. So take a minute, pause, confirm with me that we are in a good place, thumbs up on the sidebar, and then I will digest a neuron with you. Okay, thumbs up on the sidebar to make sure we're on the same page and we're ready to go. It's Josh's birthday. Is Josh online? Is he connected right now? Somebody text Josh in the group chat. Alright, Josh. We're gonna watch a happy birthday video for you in the end. Okay, so let's digest this picture. This picture is what we would refer to as a neuron, which is the fancy biology way of saying this is a nerve cell. So neuron. Okay, neurons are going to be very different than any other cell that you have seen, you know, in your biology experiences. You've probably seen a neuron, but neurons are very different. They're not your typical shape where you have, you know, like a blobby animal cell. Okay, this particular cell is long. It is elongated. It has the ability to conduct electrical messages. It's almost like it has, it's kind of like a wire. And I think of wires are really thin and they are, they're ductile. And that whole property of being thin is going to allow it to conduct electrical messages. We basically took an animal cell and like we stretched it out into like a long, stretchy, wiry little material, which is specialized in order to conduct electricity. So it's not just the fact that it is ductile and it's been stretched out, it's also a surface area to volume evolutionary advantage that these cells are structured the way that they are. Okay, neurons are going to be electrically excitable. So I'm gonna definitely need to shrink this down because this is entirely way too large. Okay, they can be electrically excitable, and the other thing that you need to know is they're not just electricity based, they also are able to send chemical messages. So when we talk about neurons, we refer to them as electrochemical cells, or they are able to send electrochemical messages. Okay, what you need to be aware of is that the chemical component, so I'm going to do a little bit of highlighting for you. The chemical components of this what? Hold on. Oh no. Really? That's really exciting. Okay, hold on. The chemical component, the chemical components are going to be in the beginning, and the chemical components are going to be found at the end. That's the chemical component. As opposed to the electrical components, that's entirely, again, way too large and doesn't look different enough, so let's shrink this down. The electrical components are going to pretty much be the insides. So this is all electrical in the middle. Chemical messages come in from one side and electrical messages transmitted through the middle of the cell, and then there will be a chemical component that is then shot out the other side. Josh just arrived. Hey Josh, happy birthday. I feel like I should sing to you, but I'm a really bad singer. Yeah, I'm not going to do that online. That's why I draw the line. Yep, nope, not singing. But we will watch a video in your honor to wish you a happy birthday. And we'll do that at the end. Sophia said, do neurons have a nucleus? And the answer is yes. Yes, there is definitely a nucleus. And it's really good that you asked that, because this part right down here, this green circle, would be, and I don't want this in a bulleted list. No bulleted list, no. Okay, and I need to shrink this. Okay, this little green circle over here, this would be the nucleus of the cell. And the nucleus is sometimes referred to as the... Nope, that's a lie. Okay, the nucleus is going to be embedded, or like the core part of what we refer to this entire structure, like this whole, this part. We refer to this as the cell body. So, lie. Okay, I just want to copy you. That's all I want. Copy, copy, copy. And I'm going to put you here. Okay, and I'm going to label this the cell body. Another name for the cell body is the cyton. and the nucleus is part of the collective cyton or cell body. Okay, so neurons don't replicate though, right? Yes, Sophia. Neurons are going to be arrested in the cell cycle. You know, there's like G1, there's synthesis, there's G2, there's mitosis, and any other cell would just go through that cycle nonstop. And in the beginning of embryonic development, those neurons are going to do that, and that's why you make more brain cells as the embryo is developing. But there comes a point in time where nerve cells no longer enter the cell cycle. They kind of branch off and they enter that G0, like, you know, or G0 section where they're no longer growing and dividing. So they get arrested in the cell cycle. So are we on the same page right now? Good. Just give me a thumbs up to make sure we're good. Okay, neurons are. How does neurogenesis work then? Okay, Brandon, I actually hate to admit this on YouTube in front of the entire world and the internet, but my brain is not actually operating on all 4 cylinders. If this was like a 4-cylinder engine, my brain is not operating, and I actually don't know what you're talking about right now, and I know you definitely know what you're talking about, and I have to think about that. I have to think about it. How does neurogenesis work? Are you talking about the genesis of new neurons? Ask me that question and remind. Ask me later. I can't believe I just admitted to the world and the internet that I don't know something. Okay. Okay, so here we go. There is going to be some sort of electrochemical messages. Okay, Sophia, is multiple sclerosis when nerve cells rapidly die? Yep. Okay. Stem cells, I think, at Brandon Lim. Oh, because she's talking to Brandon. Hey, Nick. Hey, buddy. I actually think we have everyone here. Okay, Josh, this is the stuff that you were supposed to read over the course of this past week and you were working on. It was the nervous system. So you guys had to read the chapter, and there was a couple of assignments that I had you guys work on, which would have led you to this point that we could talk about neurons. I'm pretty sure you did it. Hopefully. Okay, some sort of electrochemical message is going to, not the lie, some sort of chemical message is going to be received, and that would be my initial stimulus. So I'm going to go over here, and I'm going to do a little sketchy. Let's go, oh, that's a lie. We should probably do it this color. Magic pen, creative pen. Okay, so some sort of electrochemical message is going to be received, and that could be some sort of neurotransmitter from another nerve cell. It could be some sort of, stimulus that's being received because you just put your, hand on a stove and it was like really hot, and there's some sort of like temperature or pressure sensor that is inside of the, your sensory organ, which is your hand, and some sort of message is coming in. That would be some sort of chemical or physical stimulus that's coming in. When that chemical or physical stimulus is coming in, you are going to have a whole bunch of ions that are hanging out in solution in the human body. So I'm going to shrink this down. I gotta get rid of this bulleted list one more time. We have a whole bunch of ions that are dissolved in the fluid of the body. Okay, and there's actually something really important that is important about these ions. If you, I'm pretty sure at this point every chemistry teacher has spoken about this, but ions are going to be referred to as what we call mobile charged particles. And these mobile charged particles, sometimes we refer to them as electrolytes. And these mobile charged particles, these electrolytes, they're really, really important because whenever you have mobile charged particles, there is a word that we use or a phrase that goes with this when we talk about these mobile charged particles. They are able to conduct electricity, which is the reason why the entire nervous system is able to conduct electricity. They are working with these ions that are going to be able to generate electrical current across their membranes. I'm going to get into how that happens tomorrow in the stream that we'll talk about. how an actual action potential is generated. But either way, there are a whole bunch of these ionic or ions that are dissolved in the body. And the other really important thing that we need to throw in here is that these ionic salts, when they dissolve, they also dissociate. And that's something I know your chemistry teachers are talking to you now, if they haven't done so already. If you have NaCl, well, Na would split into Na plus, and you would have Cl minus. Like, they would split and they would dissociate. Okay, you have things that you eat that have potassium in them. You're not eating solid potassium. If you ate solid potassium, you'd freaking explode. You're eating potassium ion because that's the stable version of it. Okay, you eat things or drink things like milk, which is calcium. Well, calcium, if you like ate calcium straight up, like, you would kind of explode as well. That's really not what's happening. You're eating calcium ion. All of those ions are responsible for you to be able to conduct electricity because they have mobile charged particles. So when you have a whole bunch of mobile charged particles, these guys have charges. And if we, hey, now, it's not what I meant to do. These guys have charges. And when we talked about the way things move across membranes, and we talked about gradients in the beginning of the year, in order for you to pass through a membrane by yourself, like with, all by yourself, you need to be small and you need to be nonpolar. Like, you want, like, that's why things like carbon dioxide diffuse across a membrane really easily. Things like oxygen diffuse across a membrane easily. Well, water, even though it was really small, water could not diffuse across a membrane easily. You needed an aquaporin. These guys are mobile and they're charged. And when they're charged, they cannot pass through the membrane. They need to have some sort of channel which is going to allow them to do that. And because they are not being transported easily, they need that channel. You start to have a buildup. And you start to have what we refer to as a gradient. There is going to be a gradient. That's so not the size of what I wanted. There's going to be a buildup or a gradient of all of these ions that are present. And if you remember from the chloroplasts and you remember from the mighty mitochondria, we had that gradient or that proton motive force. We called it an electrochemical force. That's the same kind of concept here, but instead of it being a proton gradient, it's just an ion gradient. We're going to refer to that as an electrochemical gradient. And that gradient is going to allow us to move things across the membrane and use that energy to turn around and, like, do stuff. This message is going to come in, and the moral of the story right now is, without getting into too much technical detail, the messages are going to be sent from wherever this receptor is, and enough of these messages are sent to the nucleus is going to make a decision. And the decision will be, is that an impulse that it is worth, not an impulse, is that some sort of stimulus that is worth making an action for, or is that just kind of something I should ignore? And there'll be a point in time where the nucleus is going to go, yep, that's really important. I think it is time for me to react and send an impulse. So I'm going to go here. That's a lie, because there's like a double side. No, not what I wanted. Let's go hot pink. More. Oh yeah, hot pink. There's going to be a time and a place where this nerve cell is going to make a decision. Yep, it's time to react to that, and we're going to send what we call an impulse down the axon. So impulse. The impulse will be sent down the axon. Let me get rid of this bullet. The impulse will be sent down the axon, which is this wiry looking structure. Now, all wires that you have in your house, they're all surrounded by, hopefully, some sort of insulation. So I'm going to start labeling for you really quick. In this picture, let me just copy and paste, because this is getting annoying. Copy, paste. Okay, in this picture, that's a filthy, filthy lie. No one is doing that. Okay, in this picture, this little area over here, we refer to like this entire structure as the axon. But this little spacer is what we refer to as a node. Hold on. Yep. A node of Ranvier. So actually I should label this. This entire structure collectively is what we refer to as the axon. And then there are little spaces. Like each space is what we refer to as a node of Ranvier. So like that would be a node. Let me go black on this one. Like this would be a node. That would be a node. And this would be a node. Okay, the node of Ranvier are spaces in between what we refer to as Schwann cells. So copy paste. These little structures are what we refer to as Schwann cells, which was discovered by a gentleman whose last name was Schwann. And this is a Schwann cell. Like, that's a Schwann cell. That guy. That guy. I can't curve really well. And that guy. Okay. Now, the way that this is looking right now, I kind of want to relabel this, and I'm going to have to freehand this for you. We're going to call the actual wire that runs through all of this the axon. Either way, this entire middle part collectively is responsible for sending an electrical message that we refer to as an impulse down the wire. All of the wires that are in your house are hopefully surrounded by insulation. The axon would be the wire, whereas all of these other things, like those Schwann cells, they would be the equivalent of insulation. Okay, if you don't have insulation on a wire that's inside of your wall, that's really problematic. You're going to start to like electrocute things inside of your wall, and if you've ever touched a wire that doesn't have insulation, like you're gonna electrocute yourself. There are certain diseases that are out there that are characteristically known for people who like shake, and I think of something like Parkinson's disease. Okay, I think of things like MS. Okay, in those particular disorders, what is happening is that, you know, I think Sophia said like, oh, the nerve cells are rapidly dying. Yes, but more specifically, it's not just the fact that the nerve cells are dying so much as that the actual composition of that insulation that's surrounding the axon is degrading over time, and that's really problematic. If I think of touching a live wire that has no insulation, like I'm gonna electrocute myself. I want you to think about it in the human body. Like, this is a giant wire that is sending an electrical message, let's say from like your toe to your brain. Obviously, like, it's actually from your toe, it's like your giant sciatic nerve, so it like runs up the length of your leg. I want you to pretend for a second like there's no insulation in that entire wire. That's why you see people who have shaking in the perimeter, in their extremities, because the breakdown of that insulation is causing you to pretty much send electrical messages other places are not supposed to be. So the muscles are getting electrocuted. You're seeing people who have muscle contractions that should not be happening because that electrical message was not meant for them. The electrical message was meant to go to the brain. The electrical message was meant to go somewhere else, but that electrical message is kind of like being leaked out of the axon and causing you to electrocute other structures like your arm muscles, your leg muscles, like your hands are shaking. All of that is because you have a breakdown of the insulation that is surrounding the axon. All of this electrical message is basically being sent down to this area over here, which is collectively referred to as the terminal branches. So I'm going to label, and I actually want to get this out of here. I'm going to label, and it's just delete you. I'm going to label, oh no. Okay, I'm going to label this guy over here. Let me put you over here. Nope, where'd you go? Paste? Paste? Where are you pasting? Copy paste. Okay. I'm going to label this guy over here. This is what we refer to as the terminal branches. And the terminal branches are going to be the end of this neuron. And in the terminal branches is where we have what we refer to as synaptic bulbs. And in these synaptic bulbs, we are going to find a whole bunch of different chemicals that we refer to as neurotransmitters. These neurotransmitters are going to then be released out into the synapse, which would be the space over here. There'd be like another neuron, and this entire process would then continue. We would send this electrical message somewhere else. So, I'm gonna hit the pause button really quick because I don't think it's in me or you for me to keep going. It's been an hour and 5 minutes. I think today we call it a day. I can do some sort of reflex arc with you, and then tomorrow, and then we can get into an action potential. And the more I think about it, this could definitely be 2, if not 3 streams if we take our time and we go through it slowly. That's totally fine with me. But I think we're done for tonight because I don't want to overwhelm you. I'm looking right now at the side chart, and I'm seeing neurons don't replicate, is multiple sclerosis, they rapidly die, stem cells, I think. Okay, so the creation of new neurons, yeah, okay, so the creation of new neurons, Brendan, I'm thinking what Lily's saying, that is probably some sort of stem cells that have not differentiated yet far enough and have not hit the point where they have entered G0, so they can continue to grow and divide because they have not entered G0. Josh says, I mean, what's the whole unit name? Oh, you mean the domain. What I have decided for the sake of Crazy Town, because we're in unprecedented water, I usually did communication as one domain, and then I did regulation as a different domain. And what I decided to do this year, I even did it before this whole thing broke out, but I thought about, I kind of put some regulation things into evolution because we were talking about like regulation in terms of evolutionary switches. So I kind of reworked some stuff, and then I decided to kind of reorganize communication and regulation and kind of wrap that together into a bigger picture. So I don't really know what I'm gonna call this. I'm gonna call it communica regulation. Let's just call it the Corona Chronicles. If I had to officially name this, I would go with the nervous system for now. But this whole kind of concept where we are right now is going to be regulation and communication. Like there's regulation and communication tied together in this what we're talking about. Okay, so Sophia said, could there be a potential cure for MS? Absolutely. They are looking into that. The problem is that you would probably need to remyelinate this sheath. You would have to provide a way for you to re-insulate it. And I don't know if you remember watching Lorenzo's Oil. We were taking a look at that degenerative disease that was going on, and I don't know if you remember the puppies that were shaking. I don't know if you remember that part of the movie, but Lorenzo's mom and dad were trying to find a cure where they could remyelinate the nerves, because whatever disorder Lorenzo had, it had started to break down, like so many different things. But part of the problem is that the fat, he was having a problem with the competition of the 2 different types of fats, and in that process he demyelinated his axons, so it became really problematic, because that's part of the reason why he was having like all of that shaking that was going on. If you watch the movie, there were these shaking puppies, and they were suffering from the same kind of demyelination that was happening. And there was a case study that they were looking into in that movie that they were referring to, where they were talking about trying to remyelinate the neurons of those puppies. So yeah, there's definitely potentially a cure. The problem is execution. Like, it's not like you can go into someone's brain and turn around and take all the wires out and replace them. Like, an electrician could come to your house and replace a wire that is no longer insulated. Like, how do you go into someone's brain and turn around and take out specific neurons that are demyelinated if they're all demyelinated? Or like, how do you turn around and you then isolate the nerves that are like in the legs, like in the arms? Like, usually it's such a systemic and widespread problem that it's really difficult for you to get that treatment, because you have to pretty much hit all the nerves. It's not like, just some nerves are affected. And usually it's more of a treatment. Like, it's I don't know what's the right, let me rephrase that. It's more of like you are making the symptoms less painful. I don't know what the right word is there, than necessarily a cure, because a cure would imply that you are turning around and you are fixing the problem, and the person will no longer have that problem. Where I think right now they're more looking at like a therapeutic approach, where they're trying to make the symptoms less severe and less painful for people, less debilitating. So I'm just going to take a look one more time at the sidebar. Okay. Josh, Josh, you crack me up. I miss you guys so much. Um, okay, I think that this will be it for the night. I've been yammering now for the past like hour and 10 minutes. So what I'm gonna have you guys do, heading into the next stream, I'm gonna post probably like in the next couple of minutes. I have a few clips on YouTube that I just want you to watch. You don't have to go crazy taking notes. It's not like a PDQ where like I want you going crazy with note taking. I want you to watch the videos and like maybe jot down a few questions, jot down a few concepts. Just be prepared and watch those videos with the understanding that I'm going to talk to you in more detail about them. But it would probably be really important for you to like watch visually, like you read about it in the book. But sometimes people are very visual and they need to see it. So I'm going to have you watch a couple of videos before we get into tomorrow's stream. And then I will stream one more time for you on the nervous system. I will condense and shorten it down. I probably will need about like another hour. So we'll do same time, same place tomorrow. And then I will do my best to try to stream for you earlier in the day, you know, starting next week. But you hear what goes on here. Like it's really, really difficult for me to be able to sit down and have an adult conversation with you about things, you know, that are AP Bio related when, you know, like my biggest, you know, I got kids running around who are like, my comforter fell off, like I need to trap a leprechaun, like I just poured this entire pot of water all over the floor because I felt like it. It's difficult. So I will try to get on to stream a little bit earlier, but I'm going to go same time, same place tomorrow. And then if anyone is like adamantly opposed, like you cannot be available to stream live at night, then let me know. Either way, the videos are always recorded for you, so you can watch them whenever you want. And even though I can't like physically be at a computer to stream during like, you know, regular daytime hours, I'm always available on my phone. And you can always text me and remind. So take a minute, give me thumbs up to make sure we're in a good place, and then I'm gonna say good night. And then I'll see you all tomorrow, and I'll post a link for you to watch some videos for me. Okay, give me a thumbs up and make sure we're in a good place. Thanks, Michelle, for showing me signs of life. And I can't tell who that is. And Josh. Okay. Alright, guys. I'll see you all tomorrow. Sophia, you're very welcome. You're welcome. Brandon, good. Thumbs up. I will see you all tomorrow. I miss you all so much. Let me know again if 9 p.m. is not a good time for you. Otherwise, I think that this might be the best time for all of us. I'm going to end the stream. And I will see you all tomorrow. Goodbye.